Okay, in this video, I want to take a look at another introductory problem to this section. And that is a type of word problem that illustrates how we could have an equation with variables on both sides. And it says Mary drove 4 hours to reach her camping spot. Driving home, she increased her speed by 15 miles per hour, reducing her travel time by 1 hour. How fast did she drive going to the camping spot? So one thing that I want to point out about this problem is that it's a distance, rate, time problem. And I often use the equation, although there are different ways of representing this, that distance is equal to rate times time. Now, when I have this type of problem, I can usually set up a table that goes like this. There's usually two things happening. One is that Mary is going to the camping site, and the other is that she is coming home. All right, and so I'm going to draw some lines across here. And then the next thing that we're going to have here is I'm going to put in the column headings D is equal to R times T. So I have three columns, one for the distance, one for the rate, and one for the time. Now, let's see if we can find some information about these three quantities, both for when she was going to the camping site and coming back from the camping site. So it says Mary drove 4 hours to reach her camping site. So 4 hours, that's a time, and that's going to the camping site. Driving home, she increased her speed by 15 miles per hour. So coming home, we don't know how fast she was going when she was going to the camping spot. So I'm going to call that X. But we do know that when she was coming home, she increased her speed by 15 miles per hour. And when she did that, she was able to reduce her travel time by 1 hour. So that means instead of taking 4 hours, it now took her 3 hours. Well, if you look at this problem, we're not told anything about the distance that Mary traveled. But it does indicate that she took the same path. So she should have traveled the same exact distance going to the campsite and coming back from the campsite. So in that case, the two distances are exactly the same. And we end up with an equation, or two equations here, that looks like distance is equal to rate times time, and I'll write it as 4x. And I also know that the distance is equal to 3 times, I'll write it this way. We have to put this in parentheses, x plus 15. So hopefully that makes sense. Now what we do know about the distances is that they're both the same. So from this, we can make an equation that we're then going to solve to find out the rate, which is x, that she drove going to the camping site. So I'm going to use the equation that 4x is equal to 3 times x plus 15. And I have an equation with variables on both sides. So we know from the left side we need to multiply out. We get 4x is equal to 3x plus 45. And using my to the left strategy here, I'm going to subtract 3x on both sides. And when I do that, I end up with x is equal to 45, and the units of measure here are miles per hour. So that's actually what I was looking for. I'm looking for the rate at which she drove to the camping spot. And so this is the rate that Mary drove to the camping spot. All right, and so This is a strategy that we're going to use whenever we have these kinds of distance problems, distance, rate, time problems. And we're going to use the equation distance equals rate times time. And we're going to see a couple of, or a number of examples of this in this particular chapter, in this particular section actually, and hopefully we'll get enough practice with them to see how we can go about successfully setting up equations to solve for unknowns in this type of problem.